Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Dogba Jr., math instructor at the University of Liberia. In today's lecture, I want to continue with the problem we solved in the previous video. And we said we were to solve the same problem using a different approach from this area, a different approach, the same determinant approach. So we find the differential equation of the family of curves of this equation by first finding the first two derivatives, and then we selected with the exception of y prime and y prime, we selected the coefficient, the constant coefficient of these terms, so that we found the remaining portions of the elements of the matrix. Now, this was what we got, right? Now, but we don't want to use this method by rewriting, because we rewrite the first two columns at the end of the matrix. We don't want to do that. We don't want to do that. So we raise this, and then say we don't want to. So we write y minus. Now take the coefficient. The numerical coefficient is 1. This one is this is also minus 1, and then this is just y prime. This is minus 2. This is 1, and this is y prime prime. This is minus 4, and this is minus 1. Now, so we want to find the determinant by means of the minus of this matrix. So remember the signs: positive, negative, positive, negative, positive, negative, positive, negative, and positive. So we hold the first element, and then what we do is that we run line into the first row of the first element and the first column of the first element. We'll be left with this matrix. So remember, this is equal to 0. So we will have positive y with matrix minus 2, 1, minus 4, and minus 1. The next error is minus, but we don't want to use this one. We want to use the second element within let's say the first element within the second row. So we have y. Now this is negative, so it's negative y prime. So what we do now in this case, to find the minus of this, we run line into this one, the row of this particular element, which is the second element now. We run line into this row, and we run line into column 1. So you see column 1 and row 2. And then we left with the remaining elements. So we have minus 1 as well, minus 4, and minus 1. Then we move to the last element, positive y prime prime. So for this, we run line into the last row and the first column. So we'll be left with minus 1, minus 1, minus 2, and 1, all equals to 0. So we can now carry on the matrix operation. So let's erase this portion. So I'm going to erase the first area and just leave the answer there. So we have y times 2, negative 2 times negative 1 is positive 2. Now remember, when you multiply this portion, there's a negative there. So you have minus 4 times 1 is minus 4. So we just close it with bracket. Move to the next area. Minus y prime. So minus 1 times minus 1 is positive 1. Minus 4 times minus 1 is positive 4. Then plus y prime prime. Minus 1 times 1 is minus 1. Minus 2 times minus 1 is minus 2. All equals to 0. So 2 minus times minus is positive, so it's 2 plus 4. So this y is outside. This gives us 6y minus y prime. So this is just minus 3 because we're subtracting. And then minus and minus is positive, so it's y prime, or 3y prime. Let me do a bigger. 3y prime. And then plus y prime prime. So this is minus 3 equals to 0. So this gives us minus 3y prime prime equals to 0. So I can divide each term, because I want to make this y prime prime to be the first term. So I want to make it positive. So, and also this 3 is common to the 3 terms. So I can say minus 3, minus 3, minus 3, minus 3. So I will have 2y, because 6 minus 2y, right? 6 divided by 3 is 2. So it's minus 2y. Positive and negative is negative. Y prime is positive y prime prime equals to 0. So I can rewrite y prime prime minus 2y, that's a minus y prime minus 2y equals to 0. So if we clearly look at the two of them, y prime prime minus y prime minus 2y equals to 0, or we say the 2y all over dx square minus dy by dx minus 2y equals to 0. So this is how we also apply this method to be able to find the differential equation for this family of curves. So thanks ever so much for watching. Please don't forget to subscribe to our YouTube channel. See you in our next video. Thank you.